Hi students, this recording is for Monday the 11th of October. This is class number 21 and this is the final recorded lecture that we're going to have this semester. All the rest of the ones from here on out will be live and in person. So that means we'll be back in class on Wednesday. Alright, so homework 7 is due today. Hopefully you've already submitted that. It's due by 11 o'clock on Monday the 11th of October. And then looking forward, the next homework assignment, number 8, is due a week from today on Monday the 18th of October. Just a reminder about the project, it is due the class meeting before we go off for Thanksgiving break. And the project is worth 15% of your grade, so it definitely has the power to make or break your aspirations for a good grade in the course. And historically, the students who do well on the project are the ones who start early. And the reason for that is it gives them a chance to ask questions when they run into problems or uncertainty or have issues. But people who begin the project at the last minute don't have the opportunity to get their uncertainties addressed, and then they end up submitting something that's of poor quality. So my bottom line message is that if you procrastinate the project, it's probably not going to be very good, and you'll get a low grade on the project, which will really have an impact on your overall average in the course. Okay, so today's class meeting is about rate of return analysis, where we have multiple alternatives. And so learning how to calculate a rate of return and apply it to decision making and choosing the best alternative. Let's just review the two different rate of return analysis types we've been doing so far. So let's say that we have a cash flow where we're making an initial investment, and after that initial outlay of cash, then for several years in the future we're going to receive a revenue. Now you'll notice that there's no given interest rate in this cash flow diagram because that's what you're solving for. The unknown is what rate of return are you getting if you make some initial investment and then you have these future revenues that will come to you. All right, so if your company's doing that, then the question should be, what are you going to do with the $50,000 that you get each year? Because whether you reinvest them into the project or whether you do something else is going to determine whether you can calculate the internal rate of return or the external rate of return. And so if you're going to reinvest the funds, the revenue that you're earning, back into the same account, like if it's a savings account, or if you can take, if it's a business, for example, if you're generating profits from your business and you can reinvest it into your business so that now you're able to do even more and you're going to earn additional revenue in the future because of reinvesting that money. So if either of those are true, then you can calculate the internal rate of return. But if those aren't true, if you're going to reinvest the funds into a different account, then in that case you need to take into account what rate of return that secondary location is paying. Because the overall rate of return will be a weighted average. It will be an average that takes into account both the rate that the funds were generated by the original opportunity, but then also this weighted average takes into account the effect of compounding in the secondary account. All right. So what you're doing with the revenue determines whether you calculate an internal rate of return or an external rate of return. Now just to review, because we did it for the first time recently, let's review what the process is for calculating the external rate of return. This is one of the step-by-step diagrams that I shared with you, and what I said was you have some cash flow diagram, and your first step is to take any outflow, meaning any expenditure, discount it to the present at I sub I, which is the external reinvestment rate. And that's the thing that you know at the outset. The thing that you know at the outset is the rate of return of that secondary account. What you don't know at the outset of an external rate of return problem is what's the overall weighted average. So you'll know if you're going to take your profits and put it into a bank account, you'll know at the beginning what that bank account pays. And so that's the external reinvestment rate, and that is the rate that you're discounting your outflows to the present. Okay, step 2 is you take any money on the top half of that cash flow diagram, which represents inflows. You compound it to the future. Now remember, with compounding, the amounts get bigger with each successive year, whereas discounting, the amounts that were in the future, when they come back in time to the present, the amounts are getting smaller. That's why the verb that we use, discount, that means to move money backwards in time, and discount means something's getting smaller. Compound means it's getting larger as we move things forward in time to the future. So we've done both of those operations at I sub I, which is the external reinvestment rate. And this note to keep in mind is if there is a year where there's both an inflow and an outflow, you need to find the net amount for that year and only move the result of the net. Don't move both the inflow and the outflow to their respective locations. You just have to find the difference between the two. So you'll have a lump sum at the present and a lump sum at the future. All right, so step 3 is that then you're going to guess a value, guess some interest rate value initially, because you're going to have to discount the lump sum at the future back to the present, and then you're playing around with some guess value of the interest rate, and then you stop when the magnitude of the inflow and the outflow at the present is equal. So you just keep changing and optimizing that unknown external rate of return, I prime, until the inflows and the outflows are equal in magnitude. So that's a review of the process, and we have a follow-up practice problem today in our in-class exercise to further cement that procedure in your mind. This is the template that I shared with you before, and if you follow this template, then it'll help you to, and the labels I think here are really descriptive, to give you kind of the signpost and the ideas you need to calculate the external rate of return. All right. Now, back to IRR, internal rate of return. What I told you when I was first rolling out this idea of internal rate of return is that it's an excellent tool for initial screening, and the decision criteria we use for initial screening is if the internal rate of return is greater than or equal to the minimum attractive rate of return, then the project is suitable. But if it's less than the minimum attractive rate of return, then the alternative should be rejected. So we can use it for initial screening, but what we shouldn't do is if we have multiple alternatives, if we have an option A, option B, option C, if we're trying to figure out which one should we do because it's mutually exclusive, you shouldn't just pick the alternative that has the highest internal rate of return. On the final exam, someone will make that mistake. I hope it's not you. But the reason why you shouldn't do that is because internal rate of return, the option with the highest IRR, doesn't necessarily mean that it is the option with the highest profits. And what a company wants to do is maximize the number of dollars that they're earning, not necessarily just maximize the rate of return. And you might wonder, how is it possible that those would be two different things? And the reason why it's possible is some alternatives have a greater initial investment than other alternatives. And so let's say you have a little bit of extra money and you're going to put it into the bank. And Bank A is offering you 10% interest on the first $100 of your deposit, and then all of your deposits after the first $100 earn 0.1% interest. Okay, so that's one option. And then the other bank offers you just a flat 3% interest rate. So that if you had, let's say, $10,000, it's better to earn rate of return on the full $10,000 at 3% than it would to earn 10% interest on just $100. So it's the amount and the rate of return that comes into play in overall profitability. And that's what today's in-class exercise is going to illustrate. It's going to illustrate a case where sometimes the project with the highest rate of return doesn't yield the most profit. So what we're going to learn from the in-class exercise, the first part, is that you can't just compare projects by their IRR. That won't tell you which one is best. The only way that they will tell you which one is best is if they both require the same original investment amount at time 0. Then you can compare internal rate of return. All right. Now, hopefully you have that ICE 21 printed out in front of you. This is what we're going to do. We're going to use Excel to practice calculating IRR. And we're not going to do it just with the IRR function. That's too easy. I mean, we can check the answer with the IRR function, but let's go through that process of calculating. You know, the column titles will be year, amount, PV of amount, and then the internal rate of return. What you're doing is you're going to be solving for the interest rate that gives you an equilibrium between the inflows and the outflows. All right, that's one way to calculate the IRR. And so in part A, that's what you're going to do. Calculate the internal rate of return for each project. And then in part B, we're going to look at what would be the present worth of each alternative if we are using the MAR of 4%. So then, which would have the highest present worth with a MAR of 4%. Now, I don't have a template file that I've emailed you, but let me just show you a suggested way to get started here with Excel. It's not going to be particularly complicated. But let's just set this up together, and then I'll pause for a moment and give you some time to start crunching the numbers in Excel. All right. So our spreadsheet is going to have, first of all, a cell where we can define the interest rate. So this is going to be the interest rate, and then here is year, amount, and then PV of amount. And we're going to do all of this for option A. Let me put in another row here. I'm going to insert. So this is project A. And then over here we'll do the same thing for project B. All right, so we'll have an interest rate, year, amount, PV of amount. All right, now remember the definition of internal rate of return is it's the interest rate that brings the sum of the PVs to 0. Okay, so we've got 10 years, so 0, 1, all the way through year 10. And then down here at the bottom, we're going to have a total, okay, for each of these. This will be where we calculate like the sum of the PV of amounts. And what you want to do here, put in the amounts that are provided in the table. Here you do the PV function, and you'll just have to start with some guess value for the interest rate. So, you know, as a guess, I usually just say, well, let's begin with 1%, and then keep playing around with the interest rate so that the sum of the PVs down here at the bottom is equal to 0. Balance between the inflow and the outflow. That's the internal rate of return. All right, so let me pause for a second, give you a chance to set this up, and then we'll see if we're both on the same track. We're solving just so far for part A. Calculate the internal rate of return for each project. And if you want, once you've done it this way, you can verify your answer with the IRR function. All right, I'm going to start typing in the values into my spreadsheet, and you can continue your work or follow along with what I'm doing, whatever works better for you. All right, so if I discount these future amounts at 1%, then my total is positive. Remember this figure that I showed you before? That if you use a low discount rate, then the sum of the present worths will be positive. And if you use a big discount rate, then the sum of the present worths would be negative. So here, if I say, well, what about 40%? Then that goes negative. So what I'm looking for is the interest rate that brings the sum of the present worths to 0. So I can automate that process by using data, what if analysis, goal seek. And so my goal is that I want this total cell, C17, to be a value of 0, and I'm going to direct it to change the interest rate. So when I click OK, it's begin that iterative process of adjusting the value that is in cell B2 until the value in C17 hits 0. All right, so our internal rate of return for project A, so the IRR for project A is 12.4%, 12.41%. All right, and we do the same process for project B, where I'm going to change the value in the interest cell. So I want to set the total to 0 by changing the interest rate. And so now I can conclude the IRR for project B is 10.28%. Now let's just double check to make sure that that's right. You know, it's always possible to make a mistake. And so I'm going to do the IRR function. So equals IRR, and then I'm just going to highlight the amounts, not the PV of the amounts, the amounts. Press enter. 12%. Well, let me show more digits with this increased decimal button. Yeah, all right, 12.41%. And then verify as well the IRR for project B. All of this is review so far. We've done IRR before, but now we're looking kind of at a theoretical edge case where it looks like maybe project A is better, right? You'd be forgiven to think, well, if it has the higher rate of return, maybe we should choose project A. You know, because ultimately we've got two mutually exclusive alternatives. You can either do project A or do project B. And the overall question we're trying to address here is, which project should we undertake? Should we undertake the project that earns 12% interest? Or should we undertake the project that earns 10% interest? Just even phrasing it that way is misleading, because remember, the golden rule of the IRR is only use it for initial screening, don't use it for project selection. And let me show you why. Okay, now we've got this in sheet 1. So I'm going to make a copy so I can do some adjustments but yet still keep sheet 1. And I suggest you do the same thing, because you want to save these files, right? These, I hope, in-class exercise files are useful when you do the homework assignment. So save this if you haven't already. Let's save the file. I won't. You do though. All right. And then I'm going to create a copy. So move or copy. I create a copy. And so I'm going to call this one calculate IRR. And then I'm going to call this other one calculate PV. Okay. So now when I change around with these numbers, it's not going to mess up what I've done already. Let me delete this part. I don't need that. Now on the handout, we did part A. Any questions, by the way, before we move any further? We can pause if there are any questions related to the process we followed in calculating the IRR. So right on the paper there, Project A has the higher IRR. You know, writing it down on the paper will remind you later what was the point of what we were doing, like this illustration and comparison. Project A has the higher IRR. Rebecca says when I get the IRR function I get 0 for some reason. That may be because you're putting the PV of the amounts into the IRR function. What goes inside the IRR function should be the amounts themselves, not the PV of the amounts. I'm just wondering if that might be the problem. Yeah. So if it's already in balance. You know, the PV of the amounts are already in balance, and so you'd need a discount rate of 0 to bring it into equilibrium. But the amounts are not in balance. All right. Now, we just did part A. Now in part B, Aaron asks, would you take off points if the goal seek went to some number times 10 to the minus fifth? No. You know, if it's accurate to the nearest penny, that's certainly good enough. Even if it's accurate to a few cents, that's good enough. If you need more precision in convergence on a numerical solution, then what's available with GoalSeek, there's something similar called Solver. And in a subsequent class we may get a chance to talk about Solver, but it's kind of like GoalSeek. We don't get to tell Excel how close the answers need to be, but in Solver you can tell it the convergence criteria, and you could tell it I want my answer to be exact to like 12 decimal places, and it will, but I wouldn't sweat that. All right. Part B. Calculate the present worth of each project using the MAR. All right. Now it looks like I was saying and the following factor rate, P/A n equals 10, 8.11. So you could do this on paper, part B. You know, you could multiply 9,000 by the factor, and that would find the present worth of the annual series, combine it with the amount that's already at times 0, and you'll find the present worth of each alternative. So that's how you could do it by paper using the factor. Since we've already copied this over, let's do it with Excel. So what we're saying is our MAR is 4%. So if we change the interest rate to 0.04 for both projects, all right, so what does this mean? What's the significance of what we've just found? Here on the first tab, Project A had the higher rate of return. But I've already told you, you're not in business to maximize your rate of return. You're in business to maximize your profits. Which project is more profitable? Conclusion. Project B is more profitable. if our discount rate is 4%, then the present worth of the profits is 28,552 and 54 cents. Project A was less. You should choose Project B. Project B is the better alternative. Here in the Part C it says, explain which project should be selected and why. So could you do that? If this was a short answer question, could you explain why Project B is better than Project A? You could say something like, my objective is to maximize my returns, to make as much money as possible. And Project B makes more money. Let's say, as the handout suggests, what if you borrowed money at the MAR? So this had an initial purchase, right? You had to spend either $50,000 or spend $85,000. So if you're borrowing the money to initiate the project, Part D is asking, what does the present worth represent? These amounts. What does that represent? Anybody willing to venture a guess what that actually means? Those amounts? If you've borrowed the initial investment from the bank, then what is the physical significance of these two amounts? I'll stand here all day until somebody answers.
Is that the amount you gain after you pay back the money plus the interest?
Exactly right. That's very good. Thank you, Cameron. And maybe to extend it even a little bit further, it's the present value of the amount you gain after you pay off the bank. Because, you know, the bank is going to want the principal back, and they're going to want interest. And so if you take a portion of your earnings each year and you give the bank what is due to them, you know, how much you have to pay to retire the loan, so you give the bank their share, you get to keep some of it. Not all, you get to keep some of it. And the present value of how much you get to keep is either $23,000 or $28.5 thousand. And I'd rather have $28.5 thousand. So our conclusion, select Project B. All right, so it's really important that you understand the concepts. Not all of the problems on our tests are numerical. There are some concept questions on there. You know, like maybe I'll show you a picture and ask you to explain the picture, or ask for a short answer. And you can sometimes gauge how long the answer needs to be by the available space that I've provided. So if I just, you know, give a couple of lines, I'm not looking for 5 paragraphs. I'm looking for 3 sentences, right? But I'm also not looking for 1 word. So don't be too concise. There is a happy medium. Any questions before we move on from this comparing IRR illustration? I hope that this makes it clear why you shouldn't compare IRRs. The bottom line, maybe off in the margins, you could write lesson learned. The project with the highest IRR isn't always the project that's most profitable. And that was the case here. And the reason why? Project B took a larger investment. So even though it earned a lower rate of return, it's better to earn 10% interest on $85,000 than it is to earn 12% interest on $50,000. Even though the rate of return is less, you're able to put more money into that alternative and it generates more profit because it's a bigger thing, whatever it is we're buying. Is it a piece of equipment? Is it a server? Is it hiring salespeople? Whatever it is, it's better in this case to have the bigger project that earns a slightly lower rate of return. All right, now practice time. External rate of return. I'm going to put you into the breakout groups. We've done this before. We did the external rate of return in Wednesday's class, and I've summarized the procedure for you. Hopefully you still have that template file that I provided before. Remember, the template file is the one that looks like this. Do you have that template file? So your years until some year in the future, the cash flow amount, we break it up into the outflow, the inflow, take the PV of the outflow, we've got the external reinvestment rate and all that. All right, so I'm going to pause for a second, put you in the breakout rooms in case you want to discuss it or ask somebody a question. But let's solve the external rate of return for this cash flow. Now this isn't the same one as we already did in last class, is it? I'm just now wondering if maybe this is the same one that we solved on Wednesday. Let me pull it up from Wednesday's class. No, this is a different one. All right, good. That would have been a bummer if it was the same cash flow diagram. All right, so I'm going to stop talking, put you in the breakout rooms, and solve for the external rate of return using the procedure that's implied by this template. I'll leave this template up for just a moment. You know, once you go to the breakout rooms, you can't see my screen anymore. So if you don't have that Excel file I emailed you on Wednesday, just take a quick screenshot so you have this available. I'll bring you back from the breakout groups in about 10 minutes. All right, welcome back everybody from the breakout rooms. Let's take a look at the solution together. Here's our cash flow. Here's our cash flow, and we want to find out what is this external rate of return when we take into account the fact that the profits that are being earned are being put into a secondary account. And what the handout mentioned was that the secondary account is earning 3.5%. So that's what I'm going to put for my external reinvestment rate, 0.035. And we'll just, first of all, define our timeline. It goes down through 13 years. And then my reverse time column, which is going to be where I calculate the future amounts from. And then rather than typing in the amounts and separating it to the outflow and the inflow, let me just go straight to the outflow and the inflow. So I have an outflow of negative 15,000 at time 0. Here's going to be a net negative outflow. So it is 8500 minus 5500. So it's a net 3,000 outflow that year, then 8,500, and I already know that it's an outflow, so let me not put a minus sign there because I guess by definition outflows are negative, so I'll be consistent with that. All the rest of them should just have a 0. All right, for our inflows, we've got nothing until year 2, where it's 5,500, and a couple of years of that. Then zeros again till year 7. Year 7 should be 22,000. I fell for my own trick. We don't need to do it through 13 years. The last thing that anything happens is year 9. So I'm actually going to terminate the cash flow diagram at year 9, since that's the last thing that stuff happens. It should be years until year 9. not till year 13, because we're going to take all of the outflows to 0 and all of the inflows to the last year that something happens, and that's year 9. All right, so it is 9 minus year, not 13 minus year. All right. We don't need any of that. All right, so 22,000, 28,500, and then 33,000. All right. Now we'll do the PV of the outflows using this external reinvestment rate, and the N will be the year. Skip over the payment function and put this amount into the future value field. So we're treating it as though it's a future value that needs to go to the present. And we'll do that for all of them. And then the FV of the inflow, the rate we're using again is the external reinvestment rate. And this time the N is how many years does it need to go to get into the future. So if we're moving it forward in time a certain number of years. And I'll do that to the inflows. And now we want to add up all of the amounts. I'll delete those extra cells that I had. So sum the PV of the outflows, sum the FV of the inflows, and I have to have some guess value here for the external rate of return. So let's start with a guess of 1%, and then this is maybe the trickiest part here, is I want to do the PV function on this amount. So equals PV. The rate I'm using is the guess external rate of return. Now N is the number of years that this lump sum goes to get to the present. So it's 9 years to get it from where it's accumulated to get to the present. And then the minus of the amount. And so what I need to do is keep changing the interest rate here until this equals that. I'll do that with goal seek. And my goal is for this cell to be 24,440 and 67 cents by changing the interest rate. It goes, and we get 17.75 is our external rate of return.